Welcome back, students. Today we're going to be talking about different compounding periods and how they relate to time value of money. So far, in every problem that we've done up until this point, we have been working in terms of years. 1 year, 5 year, 10 year, 20 year, 30 year. Now we're going to get a little bit more specific and we're going to learn about other compounding periods, which are actually going to be more realistic. Okay. So as always, leave me your questions, leave me any time value of money questions. I'll be happy to make a video for you solving that. And don't forget, you can download this file and follow along. All right, so quick overview. The point of this video is to understand how different compounding periods affect time value of money questions. We're gonna learn about the different compounding periods. For example, semi-annual payments are twice a year. Quarterly payments are 4 times a year, and monthly payments are 12 times a year. All right, so as always, I just want to give a little bit of a lecture before I get into the problems. I think it's important. Now, one thing I want to point out is that the terms that are affected primarily by different compounding periods are going to be your periods, your interest per year, and your payment. So, for example, let's say you go out and you buy a car, and you buy that car on 5 years at 12%. Well, you all know that they don't let you make one big payment at the end of the year for each of those 5 years, right? Typically what it is, it's a 60-month loan. Now, if it's 6 years, it'll be a 72-month loan, so it's converted into months. So if I tell you we have 5 years compounded monthly, what's going to happen is you have your 5 years here, and we have our interest rate here, which is 12%. So look at what's happening here. So we have to take our 5 years times the 12, that gives us 60 months, and then we take the 12% divided by the 12, and that gives us 1% per month. Now, you know you have to make monthly payments. So the payment is actually going to be a dollar amount on a per month basis. Per month. Okay. One thing I want to point out is if the problem tells you it's going to be quarterly compounding, your payments will be in quarterly. If it's going to be semi-annually, then your payments will be semi-annually. Okay, that's going to be the outcome. If the problem tells you, hey, we're starting off with payments that are monthly, then you have to make sure that both your periods and your interest per year are both in months terms. Okay, all right, don't worry, we're going to get into some practice problems. I hope that makes sense. There are quite a bit of problems in this video. There's a total of 8, so I'm probably going to do the first 4 and then do a part 2 to this video because there is a lot to work through. But I think the practice is important because this really is a whole nother level from what we've been learning. All right, so let's jump into question 1, grab my highlighter as I always do, and let's get into this problem. You have just received your first credit card and decided to purchase a new Apple iPad. You charge the iPad $950 purchase price on your new credit card. Assume that the nominal interest rate on the credit card is 18%, and that interest is compounded monthly. Okay, here comes the question. What if you want to pay it off in 1 year? How large do your payments need to be? So always, what is the question asking for? What term is it asking for? Let's read it. If you want to pay off the card in 1 year, how large do your payments need to be? So we're going to be looking for payments, right? Let's go through the rest of this problem. So we're going to charge $950 to this credit card. So this is going to be the present value, right? The future value is going to be what? So I'm going to put this here, 950. And that's going to be a negative because we're purchasing it. The future value, actually, no, that's going to be a positive. Our payments are going to be negatives. The future value is going to be 0, right? Because we're going to pay it off. So we're going to start off with borrowing the 950. We're going to end up with 0. And it's asking us, what do we want our payments? How large should our payments be? Since we're making payments to pay off the credit card, that needs to be a negative. What is the term? 1 year, right? 1 year. Now, it's important here, compounded monthly. So, first off, I forgot to mention, I've updated this chart here, right? Now I have mode and I have periods. So when are we paying this? Does it say we're paying at the beginning of the month, at the end of the month? I don't think it says, so the default is at the end of the month. Now the period is compounded monthly, so we're going to do monthly. We're going to circle that times 12, which means we need to multiply the periods times 12, and we need to divide the interest rate by 12. So for my N here, this is going to be 12 months. And for my interest rate, it's going to be the 18% divided by 12, which I think is 1.5, but I just want to confirm, right? 18 divided by 12. Okay, 1.5. So 1.5%. Now this is on a per month basis. So we have month 0, 12 months, which is 1 year. And that means that this is 6 months, this is 9 months, this is 3 months. So 1, 2, 3. Okay. Okay, so we're going to make 12 payments, right? So we have everything we need, right? We have a value for every single one of our time value of money elements. Now we just need to put this into our financial calculator, and let's clear that out. I just want to read to make sure that I am supposed to be in end mode. Okay, so we are. This is in begin mode, so I need to change that. Second begin, second set. So now we're in end. So left to right or top to bottom here, 1 times 12 is 1 year is 12 months, right? 18% divided by 12. So you could do 18. And this is the way I suggest you do it. You do the division, you get the answer, and then you get the interest rate. You could put in 1.5, but when there starts to be a lot more decimal places, then it's better you do a more accurate calculation. And then present value is the $950 that we're borrowing from our credit card. And then the payment is what we're looking for, and we're going to end up with 0 future value. So we're going to compute the payment. So it's going to be $87.10. $87.10. That's how much times 12, right? We're going to make this payment times 12. That's how much our payment needs to be for us to actually pay down this credit card, assuming we made no other purchases, right? It would take us a year to pay that down. All right, so just out of curiosity, $87 times 10 cents. If we took this times 12, notice we're paying $1,045 and our iPad was only $950. So we are paying the interest on the additional amount is the actual interest that we ended up paying. Okay. All right. Let's keep moving along. Now, based on question 1, this question is based on the previous question, right? You decide you want to pay only the minimum. You want to pay only the minimum payment required by the card, which is $25 per month. If you make no other purchases on this card, look, here comes the question. How many years will it take you to pay off this $950 purchase? So as always, I like to come back here, and what I'm going to do is I'm actually going to change this. I'm only making $25 payments. So you guys will see in blue is the change I'm making. I'm only making $25 payments, and it's asking how many periods will that take? So now I can just go back. I have all the same terms, right? Compute N, 12 months, 1.5 per month, present value is $950, and compute is, this is effectively 0, okay? It's 2.6 to the negative. There's 11 zeros in front of this number. So it's effectively 0. So let's just make that 0. Now, the only thing I'm going to change is my payments. I only want to make $25 payments, right? And now I want to know how many months. Remember, key, how many months will it take for me to pay this off? So compute N. So it'll take 56.6856. So 56.6856 56.6. I'm going to do 69 months. That's how long it'll take to pay off if I decide only to pay $25 a month. So what does it say here? Be very careful. Students miss this all the time. How many years? How many years? This is not in years. So 56.69. So 56.69. Let's get the whole thing. 56.6856. 6856 months. How do we get this into years? Well, to get this into years, there are 12 months in 1 year, and the months cancel out, right? So we just take this amount, we divide it by 12. So we go back to our calculator, divide by 12, and this is the number of years, 4.72. So 4.72 years. That's how long it'll take us to pay off if we only make payments of $25 every single month. Be very careful. This is my point in this problem, is that students will get to this 56.68. They'll select that as their answer, and then they won't realize that I'm asking about it in years, and so they'll miss this question even though they were able to follow the steps. You're not really seeing what the question is asking, okay? That's incredibly important. All right, I hope that wasn't too difficult. Let's keep going. All right, so it's a brand new problem. Let's get out the highlighter. Your client has opened a savings account with $25,000 today, January 1st. This savings account commits him to make semi-annual payments of $3,500 at the end of each period for the next 10 years, okay? If the account pays a nominal rate of 6.75%, here comes the question, how much will he have at the end of the period? What is that term that they're looking for? How much will he have at the end, the future value, right? How much will he have at the end? Now, is this in beginning or end mode? It says at the end of each period here, so it's an end mode. And what compounding periods are we in? Semi-annual payments. So semi-annual times 2 or dividing by 2 if it's the interest. So let's go through this problem and find the terms. So N, how many years? So we have 10 years, but we're going to multiply that by 2. So 2 semi-annual payments. So that's going to give us 20. The nominal rate, right, the yearly rate is 6.75. We're going to divide that by 2, right? That's going to give us the rate by month. Now notice, you're saying maybe where's that coming from? That's coming from here, from this chart, right? When we go from years to any of these other terms, we need to multiply and divide by each of these, okay? All right, I hope that was helpful. Okay, present value. So we're going to open a savings account with $25,000 today. So 25. This is why I told you the present value and the future value aren't really impacted, right? And we're going to commit to making semi-annual payments of $3,500. So we're going to be making payments of $3,500. That's already, this is semi-annually. That's already in the right terms. So you don't need to divide or multiply for that, right? So it's already telling you, it's saying it commits him to make semi-annual payments of $3,500 at the end of each period. So let's put this NI, present value, future value, and then our payments. So N is going to be 10 times 2. There's going to be 20 semi-annual periods in 10 years. The interest is going to be 6.75 divided by 2. 6.75 divided by 2. 3.375. So 3.375%. Present value is the 25,000 that we're starting with. Future value is what we're looking for. And the payment is going to be negative 3,500 every 6 months, right? So here we have, let's see here. We have 5 years, 10 years, but this can also be, for example, 20 semi-annual periods, and 10 semi-annual periods. Okay, remember every 1 year has 2 semi-annual periods. Semi-annual means twice a year. Okay, all right, so now we can put this into our financial calculator to calculate the future value. Let's clear out our time value of money. Okay, so N is going to be 20 semi-annual periods. Interest is going to be 3.375 per period. Present value is going to be the $25,000 that we're starting off with. The payment are going to be the $3,500 that we're committing to making semi-annually. And we're computing the future value. So in the future, 10 years from now, 20 payments from now, we're going to have $146,274. Okay, $146,274. What are the cents here? And 13 cents. Okay, all right. Yeah, I know. Take a breath. I know there's a lot happening here. If you need to take a step back and do the previous videos, that's fine. This is definitely a step up, but it's also a little bit more realistic in terms of real problems. Okay, this will be the last question for this video, and then we'll make another part for the next set of questions. All right, highlighted. Based on question 3, if instead of making semi-annual payments of $3,500, you made monthly payments, right? Monthly payments. So $3,500 divided by 6, 583 and 33 cents a month, and your account compounded monthly. So here comes the question: how much more would you have than the account that compounded semi-annually? So what's it really asking? How much more would you have than the account that compounded semi-annually? Okay, so this is actually not too bad. What we need to do is we need to convert this now to months. So we have 10 years, 6.75. Let's write this down here. So first off, to months times 12. It's still at the end of the period, right? It doesn't. Let me see here. Okay, we have 6.75% interest per year. Is that right? And then we're starting with the same 25,000, but now our monthly payments are going to be $583.33, and we're looking for a future value. Now, these periods and the interest needs to be on a monthly basis. Right now they're in years, so we're going to multiply 10 years times 12, and we're going to divide the interest by 12 to get it in monthly. So here we're going to have 120 months. In the interest, we're going to have 6.75 divided by 12. And that's going to be the interest per month. So 6.75 divided by 12. That's 0.5625. 0.5625%. That's per month, right? If we multiply that by 12, we get back to the 6.75%. We're starting off with the same 25,000, and our payments are going to be $583.33. So now we're looking for the future value. Okay, let's put that into our calculator. I'm going to second clear the time value of money. But here I have the interest, but what you can do is, if you've already erased it, 6.75 divided by 12. Because there's likely more numbers after this, I would just put this directly into the interest per year here. We know that this is actually per month. We have 120 months. And then our present value is 25,000. That's what we're starting off with. Our payment is 583 and 33 cents. And we're going to compute our future value. So we have 148, 596, 41. 148, 596, and 41 cents. Okay, that's what we are getting when we convert to monthly. But the question specifically says, how much more would you have if we use this monthly, right? So this was semi-annually, 146,274.13. So we're going to subtract that, right? Minus 146,274.13 cents. Okay. And we would have more 2,322.28. 2,322. What was it? 28 more. This is how much more we would have simply by converting to monthly compounding. So if you gave me this answer, you're not wrong, but you're not right. Okay, so you need to make sure, I don't know how many times I need to say this, make sure you understand what is being asked, because it's really easy to make this mistake on the exam. And to be transparent, both of these solutions are likely to be on the exam, so be very careful. All right, that is question 4. I'm going to stop here. I'll do questions 5 through 8 in the next video. I'll see you there.